Hi guys, good evening. Welcome back to RAS Aquaculture's webinar series. So can everybody on YouTube hear us clearly? So we have 10 participants on the line at the moment. So we have 13 of them at the moment. Hey Kev, good evening. So Kev has joined 3 webinars in a row, if I remember correctly. Let's see who's online. So for the guys on YouTube, hope you guys are hearing us just fine. For the guys on our Facebook stream, hopefully you guys are hearing us just fine as well. Alright, so where's everybody from today? It's 8:23 over at our side. It's gotta take us 7 more minutes before we start our webinar. So good news for our fellow Malaysians who are on the line. Government just announced that we are going into CMCO period, which means that we should be able to continue courses pretty soon. For those who are in Johor, hopefully you guys can join. And for those who are out away from Johor, you can probably join after the movement restriction is removed. Then you guys can probably pay us a visit over at Kluang, Johor. So anybody here have already started their culture? Has anybody started their biofloc shrimp culture? Any problems that you are facing at the moment? Do let us know. So probably we can answer some of these questions during the webinar sessions or after the webinar session. Okay, so I got a question. What's the best way to contact us making DIY feed? We can probably share with you some of the formulations that we have at the forum on the website. So you can probably remind us tomorrow, then I'll just drop in the formulation. So formulation of feed, it's not too difficult, but it's a bit tedious to do it, especially if your farm is quite small. So it probably take you maybe an hour an hour and a half to produce 4 to 5 days worth of feed. Then you have to redo it all again. And also on top of that, you probably need some other raw ingredients like soy meal, fish meal, MBM, and you probably need some binder, guar gum, or gelatin, or even you can use starch as well. So these are some of the methods that are popular with feed making. So do let us know what sort of materials do you have, raw materials, and what sort of binder that you are using. So and you probably need some equipments as well, like a pelletizer, which I think you can get it quite easily. Probably a steamer to sort of bind up the feed if you're at a small scale production. So good news for you, if you're making sinking pellets, it's actually much easier to make than floating pellets. So I have never made floating pellets before, but no problem making sinking pellets. So I can probably share a little bit more on so we have a nice Excel sheet to sort of calculate the protein content. So do drop us a question on the forum, and probably you can answer some of those. Good evening, guys. So we have 14 packs for at the moment, so not too big of a crowd today. So today's topic is quite dry and technical. I would expect more of the more seasoned followers in the channel or the group would probably tune in for this session. So hopefully you guys get to learn as well. Alright, 3 more minutes before we start. So has anybody here has anybody here are you the anybody here joining the webinar for the first time? If there are people who are joining the webinar here for the first time, do let us know. If not, I will try to skip off some of the introductory part so we can save a bit more time and get right to the point. So do let us know if you're joining the webinar for the first time. Do let us know. Any first timer on Facebook? Alright, so sir, tell me about the water parameters for Magnesium and the DO level have to be maintained also for the production from a 15k liter tank. So general water parameters include salinity, maintain it about 10 ppt, maintain your DO above 4 ppm, right? So the production per ton of water, it's about 5 to 7 kilos. So 15k is 15 ton of water multiplied by 7 is 85. 85, that's about 80. Just let me double check my numbers. That's about 100 kilos, right? Of production per cycle. So use 15 cubic meter multiplied by 5 to 7 kilograms per cubic meter and multiply by 4 cycles a year. So that will give you your annual production rates. Hi, Chin Hong, good evening. Alright, so we do have some newcomers. Okay, so it's 8:30, so let's start. So start 8:30 sharp. Okay, so for those who are new to this channel, my name is Yit. So I'm the principal consultant for RS Aquaculture. So my role is really to design and operate RS systems. We have also quite an experienced team running biofloc systems. So we have actually run different type of biofloc systems. And for those who are into fish farming as well, we have actually recently just started a biofloc for tilapia systems. So that's new. So basically biofloc is originating from a wastewater technology. So that's what we are really good at. Okay, so for today, we are actually covering some of the commissioning and optimization part. Right, so when you're commissioning a farm, you probably need to use some sort of what we call consumables in your farm. So that's what we are here to talk about today. For those who have not joined the previous webinar session, I've actually gave a webinar on the type of equipments that we are actually using, that we have. So this is not a new piece of equipment. We have actually done this for our pilot during last year, 2020. So you can look at some of the results and some of the equipment design in the previous webinar. So for those who are not very familiar with our topic on the equipment design portion, do go back and revisit some of the webinar that was released earlier on. Okay, so that's where we were last webinar, and for this time we're actually doing the commissioning and optimization part based on the consumables that we will be using in our shrimp farms. Okay, so for those who are new, the pilot system looks something like that. So do revisit some of our webinar in the previous session to sort of have an idea of what we're actually talking about. Okay, so some of the performance data that I have actually covered this in extensively 2 webinar sessions ago. We actually managed to do a zero water exchange, and this is really important when you are considering the aspect of consumables, because Water exchange is very costly, as you will see in a few slides later on. Our survival rate was actually 80%, and our yield was about 7 kilograms per cubic meter, and this is without partial harvesting. I think with partial harvesting, we could probably hit about 10 kilograms per cubic meter. Our DOC was duration of culture was 83 days, and our stocking is 485 shrimps per meter cube. All right. So for those who have been following our Instagram, Facebook, at the moment we have actually finished our nursery cycle for 15,000 shrimps, and we will be transferring them out into our new growth facilities that I have yet to share on our channel. So I will probably share them maybe a month from now. So what you guys are seeing is actually about 1 month in delay on our actual R&D research. So very, very close to our actual R&D cycles. Okay, so this is how our pilots will look like. Okay, so apart from the equipment that we have actually talked about extensively in the previous webinar, this webinar is really about understanding what are the consumables or what are the sort of chemicals or ongoing expenses that you will need to run your shrimp farm. So the number one, first and foremost, that I will spend the most time talking about is salt. Okay, salt is really important. So for those who have seawater access, kudos to you. Really huge advantage in terms of production, in terms of production cost, right? And also second point is for feed. Feed is quite a substantial cost when it comes to producing shrimp. I would say for a farm that is running an outdoor pond farming, I would say 50% or 60% of your OPEX will actually be involved in just feed. For those who are running indoors, because you have higher production costs due to higher rental, power, and a little bit of cost associated to salt, so feed will get diluted to about 30 to 35% depending on where you are. Okay, so molasses is also another important core part of the consumables that we are actually using. Okay, so probiotics, prebiotics are also very popular, especially for those who are just about to embark on their biofloc journey. Very eager to use probiotics and prebiotics to ramp up your microorganisms in the biofloc system. While that's all fun, do take note of the cost that is involved, because probiotics, prebiotics are quite expensive, especially in the probiotic sector. So do have economical basis for trying to use them. So if you're not very sure about probiotics, check out the webinar that is done by Shikin during the last session. You can have a basic on the prebiotics and probiotics, and we have actually also explained to people how do we do benefit to cost ratio analysis on whether is it worth it to use probiotics, right? So calcium is also another important component when it comes to RAS systems and biofloc systems, and this will sort of determine what of your consumables. I wouldn't say it's a major item, but it's one of the key items that you probably need on an ongoing basis. That goes the same for magnesium and alkalinity. So alkalinity is what we call KH, or the buffering capacity of the water, or it's also commonly known as what is used to maintain pH. So pH, alkalinity, they're interrelated, right? So power, it's also an important component. So don't underestimate the power cost, especially when you're generating a biofloc shrimp farming system, because biofloc systems are very energy intensive, right? So this is very important. So for the guys who are in Indonesia, I don't know whether we have any Indonesians out of the 24 viewers that I'm seeing on YouTube, but Indonesia has very cheap power costs, and if you look at the adoption rate of Indonesians using biofloc, it's actually quite high. Same goes for India as well. So it's a popular destination for biofloc. But if you switch over to, for example, Philippines, which has high power costs, is not that attractive because of the higher tariffs that Philippines has at the moment, right? So oxygenation is also another important component. So when I refer to oxygen, I do not mean air. Okay, so air can be sort of produced by a blower which can be powered by electricity, right? So for us to hit very high yields, high stocking density, at some point we do have to supplement with pure oxygen. So there are a couple of ways you can get pure oxygen. The first way being you can buy an oxygen generator. So those who are for for those who have elderly at home, you probably have seen this before. It's an oxygen generator. So it generates pure oxygen, which you can then use to sort of provide that additional boost to your aquaculture product and to increase the stocking density. So for us, we do that as well. So previously in the pilot, you have actually used welding gas oxygen cylinders, as you can see over at the corner of the shop lot, right? But this round of the time, we actually bought a oxygen generator on our site, right? So this is really to ramp up the production rate, to improve the stocking density. Okay. Okay, so the first key component is salt. All right, so salt. So obviously you would want it to be high salinity, right? So we know from experience that usually salt it takes about 1 kilogram per cubic meter to raise 1 ppt. That's the typical average, right? So good sea salt would usually have a very balanced alkalinity, calcium, and magnesium. Okay, so what do I mean by that? So typically, how do you test whether a salt is actually a good quality or a bad quality is to sort of use the sea salt that you have, dilute it in water, make 25 ppt, and measure the alkalinity, calcium, and magnesium levels. So when I say something is really very good, is that when it has an alkalinity of at least 200, have calcium values of 400, and have magnesium values of 3 times, which is about 1002 to about 1004 ppm, right? So in most of the commercial salt that I've encountered, it is very, very rare to have a salt that would carry this textbook value of alkalinity, calcium, and magnesium. And when they do, they are often in very expensive brands like Red Sea Coral Pro Salt, or even some of the salt that are actually used to culture reef. So these kind of salt that are that are about $70 per 25 kilos are mainly used in the hobby industry, right? So that's really used in a very fine-tuned, a very controlled manner, right? So I wouldn't really recommend trying to use such an expensive salt for shrimp culture. So my experience on this is actually to give and take, to find a brand that is both affordable, but doesn't have very terrible value in terms of alkalinity, calcium, and magnesium, right? So you have to have an understanding of what are the current values of your salt at the moment, and sort of see what are the additives that you need to put in to make it up to the desired value that you're looking at, right? So for sea salt, try to use sea salt only. If you are able to use what we call semi-dry salt, that will be even ideal. But a cautionary note is do not try to use iodized salt, right? So I got an interesting question from Kev saying that, can you use Crater Lake salt? Probably you have to give me more details. Where is this Crater Lake situated at? If it's not a seawater based kind of salt, I wouldn't recommend it, because I've had some experience trying to use salt which is not originating from the ocean, which has good values of alkalinity, magnesium, and calcium, but somehow when you increase the salinity, it doesn't perform as well as what is expected. All right, so really important, take note of this. All right, okay, so take note of this. Usually how do you spot the issue with salt is when you increase to higher salinity, what you tend to see is that the animal, it doesn't seem to be very active, right? So it's probably due to some issues with osmoregulation. So salt is a really key component. I'll give you some of the costing with regards to salt and why is it really important in the next few slides, right? So the next expensive item is what we call, the next expensive item is actually what we call feed, right? So feed is a key component in shrimp culture, and you do get a varying different qualities in terms of feed. So the first and foremost, one of the most important specs that you have to be looking for in terms of feed are crude protein, right? So usually, for example, you are actually able to use proteins that are like feed that are about 36% crude protein, which is the common kind of protein levels that used for vana meat. But you know, obviously, if you use a lower protein feed versus a higher protein feed, your shrimp will probably grow faster at a higher protein feed. So then you have to weigh in terms the difference between faster growth and being more expensive, as opposed to be using a cheaper feed and, you know, sort of stretching the growth cycle up by another 10%. But for the indoor guys, I would always be more certain that you probably have to reduce down your culture cycle to improve the yield, because your rental rates are sort of more expensive. Yeah, all right. So that's really important. Do take note. Okay. So okay. So this is to address that. So first criteria, look at protein content. Okay. So for those who are planning to use your own, to make your own feed, that's not really ideal, but given the circumstances of where you're at, probably you have no other choice. But okay, so when you're selecting some of the raw materials that you are planning to use for feed, so one of the popular raw materials are silkworm pupae or some other very high protein feed. The problem with using things like bugs and BSF is that yes, it has very high protein content, but it doesn't mean the amino acid profile is suitable for shrimp. So that is still under a R&D phase. Don't just get carried away by protein content. Do have some background understanding of what we call the amino acid profile, and what are the digestibility of the shrimp with regards to that amino acid or that amino acid profile, right? So when you're talking about feed, the next thing you need to talk about is FCR, right? This is the feed conversion ratio. So it basically tells you how much feed you require to gain 1 kilogram of shrimp, right? So we have also seen that given the same crude protein levels claimed by manufacturers, you get different varying FCRs, right? So this depends on the quality when they were produced. So some of these also affect FCR. But take note, in our practical sense, I would say that the most significant factor that affects FCR is how we feed the shrimp. Okay, not so much on the feed side. It's more of a management issue instead of a raw material issue, right? So for us, you can also buy shrimp that are pellets that are sinking or floating. For us, we are using a sinking feed at the moment. I know some people are trying to use a floating feed in a biofloc system. I've seen shrimps being able to adapt to a floating feed, but for us, I don't think it's necessary. So at the moment, we are still sticking with the conventional sinking feed. So pellet size is also another important point. You can't be using the same pellet throughout the whole cycle, right? So for you are planning to do your own feed, do make sure you have a different extruder. You know, you have a different size for your die on the extruder, because when the shrimps are smaller, they tend to feed on smaller size pellets, and when they get bigger, you need to increase the pellet size, right? So this is to ensure they are a bit more optimal, right? So this is really important to do take note, and these are some of the specs with regards to feed. All right. Molasses is actually quite important when it comes to maintaining a biofloc system. So molasses can be viewed as a prebiotic in some circumstances, or it can be viewed as a carbohydrate source that is used to grow the biofloc. So apologies for the outlook popping up previously. So a couple of things to look at. Molasses is the number one is the purity of the molasses source that you'll be using. Second is, are there any harmful trace element? Because essentially molasses, if you're not too familiar, molasses are basically the leftover from refined sugar, right? So you don't really know what's inside there and what's the purity level. Okay. Third, it needs to be affordable. Okay. Fun fact, we have actually not use molasses in the earlier stage in our biofloc cycle, because every time you buy molasses, it actually comes in a 25 kilo jerry can, which looks like this horrible picture in the middle, right? So when we were trying to save costs while still doing R&D, we actually use alternative sources of carbohydrates, which can be either flour or even raw white sugar. Of course, that's going to be a bit more expensive, but I mean, you can just get them from your local grocery stores. So at the end of the day, if you are able to access to a cheap source of carbohydrates like molasses, that's one option. Or if you somehow magically have a bakery and you have a lot of flour that you're just throwing away, spent flour, you can use some of that flour to sort of grow your biofloc with. And do take note that the different kind of carbohydrate source that you use will affect the nutritional properties of the biofloc. Okay, we have seen this couple of times when we switch between raw sugar and we switch between molasses. But at the end of the day, it's a cost analysis and you have to decide based on a cost factors. Alright. Okay, so the fourth most important component is what I call probiotics. So we actually have our own brand of probiotics that we've been using for about 2 cycles already, and we have actually extensively compared it with other commercial brands. So more on this on the upcoming episode, which Shikin is actually working on at the moment. Right? So a couple of tips when you're selecting probiotics. Number one, always weigh the product in terms of CFU per ml. So CFU means colony forming unit per ml. So if you look at the labeling, typically probiotics will contain 10 to the power 7 to 10 to the power 9. So do remember to pick the higher ones. And shelf life is also a very important aspect when it comes to probiotics. Because some of the liquid culture cannot tolerate too long of a shelf life, just like our currently COVID vaccine that has to be transported in very low temperatures. So these are also some of the aspects that you have to take note. So for us, we work quite closely with our suppliers and some of our OEMs to ensure that some of these are at the highest quality. So for us, we're actually using a combination of lactobacillus and a prebiotic with MOS, right? So monoolysaccharides, yeah? Okay, so the key to ensuring a stable biofloc is to avoid what we call foaming, excessive foaming or algae. If you have some of these, that means that your underlying kinetics in the microbiology is not stable, and hence you're forming a lot of unwanted microorganisms. So what I would say about forming up or kickstarting a biofloc is to do it in a very progressive manner, to do it stably. So when the water is very clear, for example, when you're just starting off to seed your biofloc, the water, because of the clearness, would allow or promote some other form of algae or some other form of microorganism that might not be so ideal for a biofloc system, right? So it's really important for us to ensure that we have a good starting point to get the correct bacteria in at the earliest possible stage and quickly populate that bacteria, right, to a critical at least into the log phase to at least sustain that kind of production values, right? So that's really important to kickstart your biofloc systems. So easier said than done. You would realize that no two biofloc systems are really the same. They do have some differences in terms of performance and acceptability and in terms of nutritional profile, right? So that's really important. Fourth parameter of consumable items that you need. Okay, so we do have so some of the pictures with regards to calcium, magnesium, and alkalinity. So why do we have to continuously add calcium and continuously add magnesium and alkalinity over time? Because these elements will tend to get consumed over time. For example, what is consuming the calcium and magnesium? Okay, so if you look at your biofloc system, look at it in terms of mass balance, right? So nothing can be created or destroyed, I mean without creating energy, right? So for us, we know that when the shrimp shreds their skin, you will see floating layers of what we call shells on the surface. So when you remove them, basically these shells are made up of calcium and magnesium. So by the fact that if we are removing calcium and magnesium from the system, we have to top up with calcium and magnesium sources, right? So you can do that with magnesium or calcium carbonate, which is commonly known as dolomite, right? You can use some form of quicklime as well, although I wouldn't recommend it. For us, we actually use calcium and magnesium carbonate, which looks something like that. The one that is purplish in nature is magnesium chloride. The one that has these bugs inside is calcium chloride. Not too sure why the bugs attracted to salt, but anyways, alkalinity is what we call buffering capacity of the water, and it's usually maintained by adding dolomite or by adding sodium bicarbonate, right? So one important characteristic when you're choosing magnesium, calcium source or alkalinity source is purity, right? So the calcium and magnesium that you buy will not contain 100% pure calcium chloride or 100% pure magnesium chloride, because it will take the refiners too much cost with regards to refining these products. So it will be probably 40 to 50% purity, right? So this is spec number one. Number two is always look at your solubility, okay? So when you're running an indoor system, it's really important that you understand solubility, because you do not want to just be topping up chemicals just to having them all sink down at the bottom, right? So if you're using a dolomite-based solution, or that will be typically the case. So when a lot of people come and complain to us, hey, why is my pH not rising? Why is my alkalinity so slow despite adding a ton of dolomite into my wastewater farm? The answer is solubility, because calcium and magnesium carbonate is very extremely difficult to dissolve in salt water, especially if you do not have the correct calcium and magnesium levels, right? So you can go and dig up more about this information, but it took us a while to figure this out, all right? So important points about calcium, magnesium, and alkalinity, okay? Depending on where you are at. So power consumption will often depend on a few things: aeration efficiency. You also depend on biofloc oxygen consumption, and more streams you consume more oxygen, you require more power. Very simple, straightforward, right? But what a lot of people don't tend to understand is that the biofloc consumes a lot of oxygen, okay? So do not underestimate the oxygen consumption of the biofloc system. In fact, the biofloc system is what we learn in our secondary school, which is known as BOD, right? So the biofloc do consume huge amount of oxygen if they are not controlled properly, right? So this is where you use up your power. So make sure your aeration is as efficient as possible. You need to also make sure that your biofloc is as efficient as possible, right? Second point is heating source, right? So for those who are in Europe or in US or North America or even some parts of Australia, I wouldn't be surprised if you come and approach us telling me that, I need a heating solution to ensure that my water is 39 degrees Celsius, right? I don't know what's that in Fahrenheit for those in the US. I think it's about 74 or 75, right? So heating source might also consume quite a lot of power in your biofloc systems, right? So the third part is actually lighting source as well. We also realize that lighting will tend to affect the biofloc as well. At our side, we prefer to use natural sunlight, not because of its technical answer like the full spectrum, blah blah blah. It's because it's free, right? So for us that do not have a lot of access to sunlight, you might want to use artificial lighting, okay? So we tend to position some of the tanks to have maximized their sunlight uptake by the biofloc systems. Okay. So I always like to refer back to this slide. Okay, so up to this point, you have a good idea on some of the equipments that are involved. And now you also have some idea on the consumables that are actually being used in the biofloc systems. So the next question is really to understand what is the cost structure with regards to some of these consumables. Okay, so that's a bit too technical or too detailed to be dived in during this webinar session. And for those who have enrolled in our course, we'll try to put a price on some of these consumables. Okay, but let me just start off with a typical scenario. Okay, so the key point here is in the biofloc system is you really need to understand how to save salt and minimize water usage. Okay, so the first assumption is, okay, so of course shrimp can be acclimated to a lower salinity, right? Okay, shrimps are urea-haline, right? So normally the lowest I can see people going is about 6 ppt, but we tend to run ours at about 10 ppt, right? So salinity is the mass of salt in kilograms per every cubic meter of water. So you can just solve for the amount of mass knowing the salinity ppt that you are trying to aim for. Okay, so for us, let's assume the first costing, right? So scenario one is some guy who's not very sure about his biofloc system, just running it for the first time, right? So assuming 1 cubic meter of water, running his own pilot system at 10 ppt, you're going to need at least 10 kilo of salt, right? So typical salt will cost you about 80 cents US dollars per kilo, right? I'm not even using those expensive ones that I saw earlier on by Red Sea that having those perfect alkalinity, calcium, magnesium, right? So you can see the cost to make 1 cubic meter of water is actually 8 US dollars, yeah? Okay, so we know from experience that 1 cubic meter will give us 7 kilos per cycle. So that means the salt from the cost alone, the cost of the salt alone per cycle is 1.14 US dollars per kilos, right? And that's very expensive. And this is on the assumption that I didn't change any water throughout the whole cycle, okay? So the key point now is if you don't recycle the salt, the economics of this business model would never ever make sense, okay? So for us, we actually been reusing the salt water for 2 to 3 batches, okay? So not so much of trying to get the correct salt. The more important concept is trying to understand how do you recycle and how do you retain the salt in the system without burning a hole in your pocket. Okay, that's number 1, okay? The number 2 costing is a person, the first one was somebody who's experienced and run a biofloc system without changing water for the whole cycle. The second guy is the guy who's running the biofloc system for the first time. As you can see that typical outdoor shrimp farms will have to change 30% of the water on a daily basis. Okay, this is without biofloc. If you were to practice this kind of practice, running your indoor biofloc system, which is not unheard of, people running biofloc, they are not able to control the biofloc. As a result, they are changing 30% of the water on a daily basis. For a DOC or duration of culture for 80 days, I've actually used up 240 kilos of salt per cycle, which costs you 192 US dollars of salt for every shrimp produced. Okay, so this is what I mentioned by if you do not recycle the water, the economics will never make sense. So having good salt is important, but most importantly, you really have to understand how to run your biofloc in a way that you do not have to change water so frequently. Okay, so what I always see is what we call the vicious cycle of water change. So it's what tends to happen over time is people will often what we call process upsets in the biofloc. And once that happens, in order to save the shrimp, they have to sort of replace the water with new water and then top up the newly added water with salt and other chemicals like alkalinity, calcium, and magnesium, right? So this process keeps happening and you keep losing money because of the topping up of the salt. Okay, so it's really common for shrimp farm like us to have sort of a retention pond where we store some of the water due to process upset, treat it and reuse again. So for us, we really spend a lot of money in the water treatment section to ensure that we can sort of recycle some of this water. And for those who have access to seawater, that's ideal for you. But do take note that seawater still requires treatment costs, right? To treat that water from the coast coming into a biofloc system. So obviously the ideal combination would be somewhere that you can run your indoor biofloc system with sort of good seawater access. But usually, there's no perfect scenario. In these cases, there will also be a lot of other farmers that are farming their shrimps in which your product will face a huge competition from other cheaper producers. Okay? So this is a really key point for salt usage. Okay, so the second thing, the second problem where I see a lot of people failing in their biofloc system is messing up probiotics, molasses, ammonia control, and power and aeration. Okay, so the typical scenario typically goes like this. Okay, so people try to grow their biofloc quickly, right? So either is they start off their water, they dump some molasses into their system, buy expensive probiotics, dump it into the biofloc system, grow it for a few days. Once they see stocking of shrimp, once they see a healthy growth of biofloc, what they do next is try to stock the shrimp. So once they stock the shrimp in their system, try to feed them, they see a hike in ammonia. Okay, and what is the next logical step is they will try to add molasses and try to add more probiotics to attempt to bring down the biofloc system, right? So what happens is the biofloc tends to grow and it will grow out of control. Oxygen level drops drastically in the biofloc system, and then this guy will try to struggle. And when I mean this guy, is actually mean what it used to be us, yeah. Then when you have a drastic drop in oxygen, what they tend to do is they try to use more aeration, adding pure oxygen, and the shrimp recovers again. Then you try to feed again, then ammonia increase again, then you try to add more molasses, and the biofloc continues growing. So it forms what we call a vicious cycle, right? So the more you try to feed, the more biofloc grows, and the more molasses you have to add, and then you go back to square one again. So at the end of the day, what tends to happen is the biofloc culture will crash. And when that happens, all your shrimp will die, all your biofloc will crash, and you have an ammonia of 5 ppm. Okay? So the alternative strategy for you is to attempt, or typical other producers is at step number 6, instead of continuing trying to grow the biofloc, what they will do is they'll try to change water, right? But then again, you have an issue of course relating to salt. So can you see how difficult it is trying to maintain a balanced biofloc while maintaining fast shrimp growth and good water qualities? So that's really hard to manage between putting the correct amount of molasses, maintaining ammonia and power, and ensuring they have sufficient power aeration, all right? And of course, changing water and try to recycling water. So as you can see, the biofloc nature on its own is really like a boom-bust cycle, right? So you really have people tend to add a lot of probiotics, molasses, then feed the shrimp, then it comes to high ammonia. To counter that, people add molasses to bring up biofloc growth. Then you require more aeration. Then after that, you have a crash. Then you restart. Okay. So the key in running the biofloc system successfully at this point is you need to know when to stop, and do not just blindly add probiotics and molasses. Because if you were to tell your water quality problem to a probiotics vendor, the only thing he's going to give you is, yeah, add more probiotics, right? Because it's good news for him. So not all probiotics are suitable to bring down ammonia. You really need to know the underlying microbiome to have an understanding of what you're trying to achieve. Okay? And sometimes you have to perform what we call a sacrifice, right? In terms of what we call sacrifice is to sacrifice temporary water quality upsets for a more resilient biofloc systems. So this is for those who have enrolled in the course, you will probably know this is what we call autotrophic system. Okay, so easier said than done. Takes a lot of experience to get to run that, but most of our bioflocs at our farms are running on autotrophic system, very stable, do not require probiotics and molasses usage. So for those who are new to our channel, when we are running our biofloc system, we only start off the biofloc with probiotics, and we only add very minimal dosage throughout certain points in time. Okay, just to share with you, I've run our crab farm and biofloc farm for about 4 to 5 years, and up to this point, I have only spent less than, I would say for the whole farm in total, less than $400 to $450 of probiotics. Okay, so it's not something that we use blindly, we just use it correctly. So that's really important. Okay, so for those that are new, right? So the key is not so much in the equipment and not so much in the type of salt that you'll be using, is really in the process knowledge aspect that you really have to understand what you're trying to achieve. Okay, so what we suggest for you is always to start with a very small pilot, right? Achieve good high FCR, you know, achieve what you are trying to understand in terms of the process, right? Spend a few years to perfect the craft, right? And then scale up. Okay, so for those who are scaling up, okay, do not forget to look at your business needs and your consumer needs, right? So for us, we are always very focused on the technology part. We're always very excited about how technology can change our business, and we tend to forget what does the consumer really need. Okay, so do spend some time in understanding what your consumer need and what does your business need as to have a prolific business, right? At the end of the day, we can't be running a business just for R&D purposes or just for our curiosity, right? So the business has to survive on its own. So I see a lot of people failing is because they do not understand the difference between R&D and commercial, right? So take some time to understand what's your pilot like, okay? So and also try to understand what's the consumer need, how much can you sell the shrimp for. Kev, I don't know, have you done any background work, but you know, what's the pricing like in Africa? You know, what's the ROI like? You know, as a person or investor who are trying to look at this business, what is your return on investment like? Okay, so that's really important to take note. Okay, so this is just once you understand the pilot, the business model, you can always scale up. Okay, so no issues with that. So for us, what we really specialize in, a part of all this technical training, is also to help people understand the profitability of the business, to understand the scalability of the business, as well as the risks of the business. So that's really important. And also try to equip people with the practical skills and things like feed making, and some of to help them network between other participants as well. I'm really excited about the opportunities biofloc do bring. I do see it changing even the fish farming sector as well as the shrimp. So that's really good news for us. At this point, I think working alongside a lot of people, especially in the biofloc industry, would be really beneficial, not just towards our business, but also as the society as a whole. So that's really important. Okay, so for those who are in Malaysia, I think we can welcome you to join us in Kuang. Okay, we charge about 1,600 per person. I know many of you can't join because of the pandemic. So for us, we have an online course option, which is only about 800 ringgit or 199 US dollars. So in the event that you have joined the course online and you decided to come to Malaysia at a later date after the pandemic, then you can just top up the differences and join the ones in Malaysia. I do really hope to see all of you in Malaysia. But I understand that if it's a journey that is too difficult for most of you to join, online course will be an additional option. In most cases, this will be the only options available at this point of time. I'll try to update you guys along the way, and so to give you some of the new updates on our farm and some of the R&Ds that we found out on our site. Okay, so that's all for my side. I'll be taking some of the questions. I'll do YouTube first, to answer some of the questions that I've seen on YouTube, and I'll go over to the participants on Facebook, which my colleague have actually compiled for me. Okay, so just let me scroll back to some of the questions that we have. So I've either answered Ridwa on the stocking density or the yield. Okay. Use of multi-minerals in shrimp farming. This is by Ridwa Saka on YouTube. Yes, some people have actually tried to sell us what we call trace element like azomite, or it contains a wide array of multivitamins or multi-minerals, or what we call trace elements in general. So when you have already mastered calcium magnesium ratios, salinity, proper DO, so these are things that I usually play with maybe only after two and a half years running in the RAS system. But it's more of the 5 to 10%, I would say. So get your basic rights first. Don't try to play with multivitamins, especially if you're in a very, very early stage. At this point in our farm, we don't use any azomite or any multi-minerals at the moment. But I think I do have some of them somewhere in the farm, given by suppliers. I probably can dig it up and give it a try. Since that you mentioned it, then I'll probably do another webinar session for you. Okay, so Kev, I think I've answered this question already. So sodium composition is a tricky one. Usually people try to measure sodium versus potassium ratios. I can't remember the ratio, but I think it's about 3 to 1. Let me double check if I remember it wrongly. So my colleague Rachel will probably have a bit more idea. Okay, so hopefully for Kev, your questions with regards to feed and composition, mineral composition, you can drop us on the forum. I'll try to reply them once I get into the office tomorrow. Okay, so magnesium and K values for evaporated sea salt. This is a tough one because usually, so strictly speaking, once you evaporated the sea salt, you are not able to measure the alkalinity, magnesium, and calcium because they tend to precipitate out as a solid. So you'll be able to measure sort of a mass fraction of it. But how do we determine what's the average alkalinity, calcium, and magnesium for seawater is the seawater quality tends to vary based on your location. For example, in parts of Malaysia like Sabah, you usually have signs of ocean acidification in which you have a lower alkalinity or slight acidification. So the best seawater I've seen at the moment till date is actually from Sri Lanka. So back then I remember it's not surprising that the crabs from Sri Lanka is known to be one of the best. Not to mention also water quality in India is actually quite hard as well. If you take the calcium levels and magnesium levels of the Indian Ocean, you'll probably realize that the calcium levels will be in the range of about 500 to 600, where your magnesium levels will be more than 2000. I've seen water qualities from Kerala, and it's not surprising that Kerala and India have quite a good production of shrimp as well. So, Mark, really a very wide question with regards to this. Seawater quality wouldn't the protein content be formulated feed that have a lower protein quality so that do not have to add so much molasses as well? That could be done. I've seen some of it in the tilapia feed, not so much in the shrimp at the moment. Because how I think of it is at the moment is everybody is still you get the benefits of lower FCR, but you know, for us, the key point is really trying to recirculate the water. So that depends on your business model. Okay, so would you use calcium hydroxide to control algae slash CO2 and give alkalinity and calcium? No. Bacteria, for example, the heterotrophic bacteria, what it does is it clouds up the water, so your water becomes very turbid. And when that happens, usually what you have the algae. But this is a really tricky part, you know, because in biofloc systems, there's not only one organism that's actually growing, correct? You have a plethora of microorganisms. You have algae, you have heterotrophs, you have autotrophs, right? So the key is really to try to balance it. I wouldn't say that we are trying to get rid of all algae, but I would like to get rid of some algae, you know. So it's really trying to run it to a really delicate point. So that's where we are trying to aim our performance at. Okay, so any questions from Facebook? Okay, so let me just read off the list on Facebook. Okay, so I got some question from Ali Tahir Dada regarding salt salinity. That's correct. Salinity do increase with the evaporation of water, but it doesn't mean that your calcium and magnesium will increase as well. Or the other way to think about it is whether the water gets evaporated, you still have to top up water in the system. Why? Because if you don't do that, you have a higher stocking density, because now you're growing more shrimp, you're growing the same shrimp with less amount of water. Okay, so from Shafiq Rossi, means one cycle means one batch of shrimp from PL to ready to sell in the tank. Yes, that's correct. Okay, I used to have a saltwater aquarium manual. Shrimp is very sensitive to change water parameter, then all shrimp die. One failure caused a whole shrimp to die. In average, how much percentage in tank crash should we expect in a year? This is quite a difficult question. I remember the first year doing biofloc, I used to have crashes almost every batches. But for the past year, I have not had any crashes for the past 1.5 years that are controlling. So another shrimps are cannibalistic. So when one guy dies, everybody has a feast out of them. So to a lot of shrimp. So that's also one other key point. Okay. So if you are close to seawater, can we use the seawater directly in our tank? This is again from Shafiq Rozi. Yes, you can. Remember to dilute it to about 10 to 20 ppt, right? And double check your alkalinity, calcium, magnesium values. Alright, so only raw salt enough to use without additional mineral supplement? No. Have to check again your calcium, magnesium levels. If you don't have enough calcium, add more calcium. If you don't have enough magnesium, add more magnesium. And if you don't have enough alkalinity, add more alkalinity. But don't keep adding don't keep adding chemicals if you cannot control the bioflora, because what will happen is you add the chemicals and you have a process upset, you'll dump out all the water and you just waste all the chemical that you just add, and you again go to the bioflora and again add your chemicals. So it's a vicious cycle. So get your basic right first before you try to you know play around with some of the trace element. Okay. Again, a question from Mark on YouTube: how often are you testing your minerals and ALK a week? Because we know from mass balance, nothing is entering the tank and nothing is exiting the tank. The only thing that's exiting the tank is shrimp shells, right? So that is which is the core consumption of your calcium and magnesium levels. Of course, yes, some of them will use shrimp to osmoregulate, but I don't think it's a big amount. So so for us, being a fully enclosed system, we know that we know it reduces, but it doesn't reduce that much in such short of a time. Okay, so for ALK, alkalinity, we are measuring, I think, every alternate days. So we are using a titration kit to do it, and we will be adjusting it on a daily, I wouldn't say daily basis, but every time we do a measurement. Okay, so I've run the clock a little bit at my side, so it's 9:20 now. Thanks for joining the webinar session. I hope you have a great time. This webinar session is quite technical, so thanks for bearing with us. So for those who are interested in the course, do enroll, and I hope to see you in our forums asking us technical questions. Always fun to answer questions. And that's all for now. You can reach us at sales@rasagroculture.com. Alright, so till then, the next webinar session will not be on shrimp. It will be on crab farming. So we'll be going through some of the foundation that we probably need. I mean the layout plan for your indoor mud crab farm. If that goes well, I'll probably do another webinar session on the layout management or layout plan for doing your shrimp farm. So hope to see you guys again. Until then, good night.